Okay, so if you know this famous scientist, Stephen Hawking, so once he said, this one's like back in the 2015, is where the AI starts to get common in our everyday usage. So it said that computers will overtake human with AI within the next 100 years. So when that happens, we need to make sure that the computers have goals aligned with ours. Okay, so this is a question here. How are we going to define AI? So many times, especially if you look at movie, we have a lot of things seems like related to AI. And there's also like, if you watch Star Wars, a lot of like robotic things seems like the robot can have their own thoughts, they can think on their own. So if you look at this part here, how we actually going to define AI? So actually AI means different things for different people. So for some people, AI is about the artificial life forms that can surpass human intelligence. So AI stands for artificial intelligence. Some people think that it is a robot, that the intelligence is way beyond human. And for others, some people also may think that almost any data processing technology can be called AI. So it's very abstract meanings for the word AI here. So for us to set the scene to understand better, so we're going to discuss what AI is, what it means, and how we can define it, and what other fields that closely related to AI. So it's not an easy explanation because for one reason, the popularity of AI in the media, especially in the movie, people start to labeling a lot of things with AI, and sometimes a lot of the things is like way beyond the things that we actually have, at least for now. So a lot of people think that almost anything from statistic and business analytics to be manually encoded if then rules then be called as AI. But actually behind those program is just basically an if and else, if then rules. So if else rules. So not if else rules all are AI. So why there's so many confusions? So we have at least three reasons. So for the first reason, there are no officially agreed definitions. So from time to time, this definition seems to change. Like let's say if we rewind back to 20 years ago, a lot of things people think things that computers can't do is what we call it as AI. So for example, here is said that 50 years ago, automated methods for search and planning were considered to belong to the domain of AI. So this one was like 50 years ago, but today, this automated method search here is something that we can manually code it, and it's taught to every computer science students. So this automating method of searching is no longer considered as AI. And other methods that becoming so well understood, but this kind of method they're going to be moved from AI to statistic. So the things here, we can't say that applications that the typical computers can't do can be labeled as AI. So it depends from time to time. With the advancements of technology, a lot of things become just we can just use the if else rules, or we can manually code it, and we no longer call it as AI. So the reason, for the first reason here, why we can't come up with a definition for AI, because there is no agreed definition for it. So we're going to look at further how we're going to define AI. And for the second reason, the reason that I just say just now is the legacy of the science fictions here, because there's a lot of confusion about this AI here because of the visions of AI is presented differently in the world of the science fictions. So usually if you watch from the movie, for example, like Star Wars, so this kind of science fiction story, they often feature like a friendly humanoid servants that provide very detailed, very witty dialogue about that particular robot. And sometimes they can even follow the steps of, like for example, like Pinocchio, and then Pinocchio start to have thinking of his own, like whether he can become a human or not. So if you look at this last sentence here, like for example, like Pinocchio, like he has his own thinking, but that's not the case like up to the one that we have today. So because of the science fictions here, so it creates like a lot of confusions. That's how our AI is supposed to behave. And for the third reason here, so this is like a very obvious reason. So what seems easy to us is actually very hard for the computer. So for example, picking up an apple. So it's very easy for us to just pick up an apple from the floor. But for a robot here, for them to like grasp an object is actually very, very hard. And it's a very active study. So recent years, we have like Google's robotic grasping object, and there's a cauliflower picking robot. So we can look at this link over here before we go further. Okay, so this is the cauliflower picking robot. So it's funded by the EU that is set to replace migrant workers for a short-staffed farmers in Cornwall. So actually, this one is quite recent years, like in 2018. So this cauliflower, this is the robot over here. So if you look at this one, it's far off from the one that we usually watch in the science fictions. So it doesn't look like a human, but it's a machine that can perform this grasping of object. So it might seem like something very easy for us, but for the robot to do something like this, to like properly grasp the cauliflower with enough force not to damage it, but enough to pick it up, it's not very easy for the robot. So a cauliflower picking robot has been developed which can tell when the vegetable is ready for harvest and pull it out of the ground without damaging it. And the vegetable harvesting can be difficult and is often inefficient, time-consuming, and expensive. So if you look at this part over here, this robot here, it can tell when the vegetable is ready for harvest. That means it has its own eyes. There's a camera here that can detect when it's suitable for harvesting season, and it also can provide enough force to pick it up, pull it out, and without damaging it. So this is the AI that we have today for the robotic AI. That's why it's not really like what the science fictions that present to us how our AI should look like. That's why it creates a lot of confusions. Okay, so the things that seems easy to us, like for example, if you look at this image here, it's just very easy for her to pick up an apple, but it's not easy for a robot to actually pick up anything. So they need to have like grasping, good grasping. They also need to able to identify the things that need to pick up. And what seems hard is actually very easy for the robot. For example, in playing chess. So the task of playing chess and solving math exercise can seem very difficult for us, and it may require years of practicing like playing chess to master and involving our higher faculties. But it turns out that actually playing chess is very suitable for computers because we can just set certain rules, and the computer they can compute different alternative move sequences at the rate of billions of computational a second. So this is in 1997 is where the computers beat the human world champion in a chess that we call as the Deep Blue vs Kasparov matches. So you also can check out this link here. So this one was quite famous back then in 1997. What happens like 20 years after the Deep Blue, how AI has advanced since then conquering the chess. So do you think like today we still consider computer playing chess as part of the AI? Okay, so this one is the link you can read on your own. It's quite a long article. So based on the things that we have discussed here, we have at least 3 reasons. So how we can actually define AI and what would be a more useful definitions. We no longer can use the terms like what computers can and can't do, because with the advancement of technology, a lot of things will become even abstract. So in order for us to define AI, maybe actually it is more proper for us to understand the properties that are characteristic to AI. These are the two properties here that we can use to characterize AI. So the first one is autonomy, and the second one is adaptivity. So what it means by autonomy here? The autonomy here is like the ability to perform tasks in complex environments without constant guidance by the user. And adaptivity is the ability to improve performance by learning from experience. From the words autonomy here, we can tag the keyword here without constant guidance. And for the word adaptivity here, we can tag the keywords learning from experience. So if you're going to define whether an object or device is AI or not, first you need to think from the perspective of whether that device needs a constant guidance. So you can ask ourselves whether it needs a constant guidance, and do they learn from experience? Because this is the things that actually define us. We can perform works we can do on our own. So that's autonomy. And as a human, we also can learn from experience. These are the things that we're going to use to define AI. So if you look back at this cauliflower here, the cauliflower picking robot, it has the autonomy here. It can perform under a complex environment, and it also can learn from experience. I believe this one won't be the first cauliflower that this robot picking up, so maybe it's already damaged like a lot of others, and finally it comes to the one that he can pick up with suitable force without damaging it. So this robot needs to be able to learn from experience, and it should be able to perform without constant guidance. So everything has been programmed and it can learn from experience. So we can define it as AI.